So I've been requested to do a Waterman method tutorial. So that's what I'm going to do. If you don't know what the Waterman method is, it was made up by Mark Waterman, hence the name, and his friend Dan Kramer. How do you pronounce that name? Anyways, it was made in 1981. It was very little known back then because there were nowhere to get the algorithms from, and it's very little known now. Except for me, obviously I know, an average 12 seconds with it. But if you just want to learn it for fun, coming from like CFOP or ROux or ZZ or whatever, be my guest. This is the right video for you. On the top of the screen is the Scramble if you want to follow along. Don't really think that's necessary. The first step of Waterman is to solve a layer minus an edge. Now, when you learn to solve a cube for the first time, you started with a full layer.
I'm here editing the video at almost midnight right now, and I forgot to mention that Mark Waterman actually solves the corners of the first layer and then all four edges. So he does the full layer and then the corners and then more edges. The simplified version, which is way better in my opinion, is just the layer minus an edge, which is why I'm teaching you this instead of just a full layer.
Here, you're going to do basically exactly that, but you're going to leave out an edge. So you're only going to have 3 edges solved in all 4 corners. Now, in my opinion, the fastest way to do this is to block build, just, randomly. Now, a lot of people do prefer to do it like ROux blocks and then these corners and then solve all the rest of the corners from the right. I don't do that. I think it's unnecessary. I think it's slower, and I'm way faster just doing it my way. So you're just going to block build a layer minus an edge, and there you go. The second step is CLL. The problem is some CLL algs that you do on 2x2 won't preserve this entire layer, and we need it to. So instead, we use CMLL algs. All 42 algorithms are linked in the description. If you don't want to learn 42 algorithms, you can just do 2-look, which is, 9 algorithms for OLL and PLL. It's the same algorithms as 2-look OLL and 2-look PLL. Through the power of editing, the corners are magically solved. I also know all 42 cases. Anyways, after the corners is going to be a rotation. So here is where you find out the reason we're leaving out an edge instead of solving the entire layer. We're going to use this as kind of a keyhole to solve the entire right layer. So what you're going to do, you're going to find any white edge, since white is our right layer and yellow is our first layer, you're going to find any white edge on the middle layer, which is this layer right here, this kind of ring in the middle. You're going to put it in the down front position. Doesn't matter if it's here or here. Now, if you bring the edge over here and it's in the bottom, you're going to see the corners that are the same color as this other piece of the edge, which is blue. You're going to bring the blue corners to the top. Since this is blue, it's going to match. And you're going to do U, M prime, U prime, just to insert it. If you end up with a case like this, where it's in the down front position and the white is on the front, you're going to find the color of the corners that are over here on the bottom, which is green. This is a white-green edge, goes here. So instead of doing U, M prime, U prime, which will just flip the edge, you're going to do U prime, M2, U. And you're going to keep doing that until the entire layer is solved. Now, there are going to be cases where it's just going to show up as flipped. In that case, you can just do U, M, U prime to take it out. And then, of course, find the corners that are the color of this, which is orange. It just so happened to be on orange. It can be on any color. And then you could just continue as normal. So U prime M2 U would fix this one. If you get a case like this where it's on this side right here, you're going to pull the color of the corners up to the top. And you're going to do U, M, U prime, which fixes it. If you get a case like this where it is practically U2 from being solved, you're going to take it out of the left layer, doing U prime, M, U, and you're going to put it back over here using U, M prime, U prime as normal. If you get a case like this where there are no right layer edges in the middle layer, instead they're in a white layer, take them out, like I said earlier, and then put them back in. And then you could just do that, repeat, until the whole layer is solved. So the last step in the method is last 5 edges. This can be done in 2 looks, even though if you do it in 1 look, you're going to have to learn like 600 algs or something, and I don't even want to learn 600 algs. That is way too much for me. So instead, you're going to learn 8 with a couple setup moves. So full last 5 edges is 32 algorithms, but that accounts for the right layer if the right layer is unsolved and the left layer is solved. For the beginner version, the right layer will always be solved, which simplifies it to 16 algorithms. And if you don't want to learn 16 algorithms, you can learn 8, because 8 of those algorithms is if the left layer edge that needs solved is in the back down position. If that's the case, you're doing M2, U2, M2, U2 to bring it to the front. It will always be on the front. Now this will confuse some of you guys in terms of orienting the edges, because the next step is to solve this into here while orienting all the M layer edges. Before we get to that, we're going to get to a couple special cases first. The first special case is if the UL edge is already solved, leaving only 4 edges. In that case, you are going to take the edge out, like so, and then you're going to insert this back over here, because by just taking it out, we messed up this layer. So what we're going to do, we're just going to insert this back here, doing this, so it brings out the edge. And then you're going to adjust for it to be facing downward. The same exact thing applies to the second special case, where it's in the layer, but it is flipped. So we're going to do the same thing earlier, take it out, insert it in the other way. And then, of course, bring it back to the down front position, and then you can do L5E like normal. Alright, so how last 5 edges works, and I know I've said this before, you're going to solve this edge into here, while also orienting the middle layer edges. There are 8 of those cases. Now the part that confused me when I was learning the method was that you can sometimes not have the blue or the green facing up top, like you do in normal Roux. Sometimes you can have the orange facing up, or the red facing up. So for last 5 edges, you do not care about the corners. You don't even care about the right layer. You don't even need to look at the right layer. You're only focusing on this big line here and this little line here. So this kind of like an arrow here, or a triangle that you need to worry about. A bad edge is if you get an edge on the top that is not the same or opposite color as the center. So this will be a bad edge since it's not orange or red. This is a good edge because it's red. That's the opposite of orange. The first case here that you're going to learn is if there are no bad edges. So you see all 3 of these edges, they are either the same or opposite of this center. So the algorithm goes M prime, U, M prime, U prime, M, U prime, M prime, U. After this algorithm or other algorithms for our last 5 edges, you're going to end with just Roux 4C, which I guarantee that you know. The second case is if you have one bad edge in the back. So I see you've noticed that we have a different color center here. This is blue. So now blue and green on the top would equal good edges, and red or orange would be bad edges. In this case, we have a red edge here on the back. That is our only bad edge. So the algorithm for this case would be M prime, U prime, M, U prime, M prime, U prime, M, U prime. The third case is if you have 2 bad edges and they're on the back and the left position. The algorithm would go U prime, M, U, M prime, U prime, M prime, U. The next case is very similar to the last case. You have 2 adjacent bad edges again, but this time they're in the front. So the front edge and the left edge is bad. The back edge is good. In this case, the algorithm would be U prime, M, U prime, M prime, U, M prime, U. So this next case, the left edge is the only edge that's good. So the front and the back are all bad edges. So the alg for this is U prime, M prime, U prime, M, U prime, M, U, M prime, U, M, U. That algorithm is the hardest and most difficult algorithm to learn in this set. This next algorithm is 9 moves. So as you see here, all 3 edges are bad. In this case, the algorithm is U prime, M prime, U prime, M prime, U prime, M, U2, M, U. The next alg is if only the front edge is bad. So these 2 are good. This is bad. So the algorithm will be U2, M prime, U, M, U, M prime, U, M, U prime. So the final algorithm I'm about to show you is the easiest and shortest algorithm to learn. So only this left edge is bad. In this case, the algorithm is M, U, M prime, U2, M prime, U. Now all you have to do is permute the midges, which can only be M, M prime, M2, or U2 moves. I don't really feel like I need to get into much details because some of the people coming from Roux already know how to do 4C. This is exactly how Roux finishes as well. Well, there's your Waterman tutorial. Hopefully you understood everything I said because I'm not good at explaining things. But if you can, go ahead and like the video and subscribe. I am desperate for viewers. And I'll see you guys in the next video. Bye.